Could you tell us how long did it take you to make the film?
And it took us years, and it wasn't just me. I mean, there's a whole team of people behind this. We have a producer in LA, a producer in Chicago. We had a visual effects supervisor from DreamWorks. Once we got the edit done, we had the sound mixed over at Paramount Pictures, and there was maybe 24 people doing the sound effects alone, just sound effects and the Foley, doing footsteps. We had Sinan Williams from the band Dengue Fever. I don't know if you guys have heard of them, but they're a very popular band. Wrote the score, and we all had day jobs, so that's why it took so long.
What advice do you have for aspiring filmmakers?
Yeah, there has to be nothing else in the world that you want more, because it's grueling and it's a sacrifice. And we're doing really well with this film. We're going to be screening at 20th Century Fox next month in LA. But we still, and we have a distribution deal, so it is on Amazon and Google Play and YouTube. It's going to be on iTunes soon.
What is that, Lewis?
It's my contribution. It's a computer. Quantum topographical.
You talked about quantum computing. So Yale's the center of quantum computing, by the way. There's a lot of quantum computing going on at Yale. The idea of the quantum computing is this whole thing you talked about, this superposition of state. That on a normal computer you have an on or an off, but in a quantum computer you have both. Right. So you have exponentially more possible states.
Right. Instead of a 1 or a 0 binary, it's everything
both.
At once. Yeah.
What is your overall goal for the film?
Our goal is to either shoot a sequel or get a TV series out of it. Something like what you'd see on Netflix with Stranger Things or Hulu, where we'll shoot 8 or 10 episodes and you can just binge on it. But we'd like to see this kind of take off as an American Doctor Who, where this God Model Project has a hand in a little bit of everything. And even though the stories are fantasy and kind of out there, we like to keep the science as real as possible. It's just a fun way to expose people to these really abstract concepts.
Now, this jam is us. We are stuck on this membrane. Nothing gets off the membrane except for one thing.
What?
Gravity. Or more precisely, gravitons.
Why did it take so long to confirm gravitational waves?
So that's a pretty well-established theory called the general theory of relativity. Albert Einstein, it's a theory of gravity, and one of the predictions of his field equations was that you'd have gravitational waves. So gravitational waves were predicted by his theory, but they had not been detected, mainly because they're so incredibly weak. So you have electromagnetic waves, photons, right? And then you have gravitational waves, which have these particles called gravitons, but they've never been detected. So it was predicted by Einstein's theory of relativity, a theory that has, any scientific theory, it's going to stand the test of time. It has to prove everything that already is explained by all the previous theories and make predictions. General relativity made predictions, one of them being gravitational waves. So the gravitational wave, that was a confirmation of his theory, and it was basically, physicists have been looking for it forever. And the interesting thing is that they used interferometry, which is basically, it was used to figure out that the speed of light was constant by bouncing light off mirrors, and it was coming back and you see the interference pattern. So they used interferometry it was like a supernova gave a disturbance in the gravitational field, produced ripples that came across to Earth, and they measured it with the actual distance that they measured was something like I think it's 1/1,000,000th of the size of an atom, which is just incredible.
It's the holy grail of physics. It makes sense mathematically, but we don't know any of it.
Are you implying you've devised an experiment that will prove the existence of superstrings?
What will happen if string theory is proven?
Boy,
well, you can prove it mathematically. You just can't. It just doesn't make any predictions that have been tested.
Right.
That's what makes it tricky. not every physicist is, some people would call it a pseudoscience. It doesn't make any, if you could find if it made some predictions, say, I don't know, predicted the frequency of gravitational waves or something like that, then what could we use it for? It's hard to know. I mean, quantum mechanics made predictions. We've used quantum mechanics extensively throughout science. We didn't know that was going to happen. This is why, why should people put money into science? Because you want to go further, because we don't know what that science will hand us.
Without relativity, we wouldn't be able to have cell phones. Correct?
Yeah. I mean, general relativity, special relativity, GPS satellites, they use that to get the positioning more exact. Because of the distances that they're away, and if you didn't use special relativity and general relativity, you'd be, say, 10 meters or 20 meters out. And then for spacecraft and everything, I mean, if you have a signal coming from something that's at Jupiter, it takes, 8 minutes to get here. So that's quite a long time.
Have audiences connected with the film spiritually?
A lot of our screenings, it surprises me, like at the festivals, people have almost like a spiritual connection to the story, and some even said it brought them comfort, and it's such a science-heavy story that really surprised me. But I think there is enough anecdotal stories out there to make you wonder.
What did the Braille T-shirt say?
That's a good question. Not everybody catches that. It's a tagline. It says, "It's very beautiful over there." Yeah.
How does infrasound affect the body?
Rapid pulse, gagging, vomiting, bowel spasms, uncontrolled defecation.
Yeah, it's actually true that the Russians tried to use it as a weapon, and it has a horrible effect on the human body where, not to be graphic, but you have all kinds of GI intestinal problems, and causes vibrations within your eye. And it's funny because they did a study actually of different places that claimed to be haunted. This was in Great Britain. And the one thing all of those places had in common was infrasound was very low. They were being exposed to very low sound waves, like a factory or geothermal sound waves from like subterranean caves. And they think that those sound waves are causing people to hallucinate in a way, and that their eyes would be vibrating. They'd think they'd see something out of the corner of their eye, see a ghost. Obviously, we used it in a different context for the purposes of the story. But if you want to read more about it, there's a great book, and I included it in the handouts, called Spook by Mary Roach. And it's actually really funny too. And she goes around all over the world interviewing people who are studying this. And some of the research is very legit, and some of it's very pseudoscience. And one of the things that that really gave her pause was she actually went in a closet and exposed herself to electromagnetic fields, helmet. And she said she felt a presence, and she could hear knocking, and she could hear sirens, and it was very unnerving for her. So that's one of the ways we kind of took all of those experiments and mashed them up into one big experiment for this story.
Can matter exist in two places at once?
When we observe the subatomic world, there are no rules. An object can exist in two places at once.
Early 20th century, they started to see that kind of pattern with produced by electrons, and then it was produced by neutrons and bigger things. So the idea is, how can you see a pattern, a wave pattern, with things that are particles? And the only way they could explain that was that these particles, these bits of matter, were in superposition of states. So they were behaving like a wave. So if I have an electron, say it's here, if the electron, the only way it can produce that pattern is actually by being everywhere at once. In other words, it has a probability of being everywhere in this room, and when you're not looking at it, if you like, it's everywhere, but if you detect it, it's in one point. So this is the idea of your ghosts.
Right, and we kind of took it a step further for the purposes of the story, where if you're observing something, it changes its position or its velocity, And what if it went even further than that, where if you were observing something, what you expected to see is what it would become. And there's a little bit of quantum entanglement involved as well that we had in earlier drafts of the script, but we didn't bring into this just to keep the story from turning into a physics lecture on the script.
Yeah, we all get carried away.
Thank you. Thank you very much.